All right, so good afternoon. My name is Jim Boss. I want to thank the City of Edmonton, first of all, for inviting ATCO EnergySense out to this forum this afternoon. And my goal this afternoon is to show you where you can make improvements in your home from simple to complex that will result in lower energy bills, reduced energy consumption, increased comfort, and increased value of your home. So at any point, if you have any questions, please feel free to ask. And we do have some goodies here, a little prize for those who do decide to ask some questions. So here are some reasons why you would want to make your home more energy efficient. By making your home more energy efficient, you immediately reduce your energy bills and will be less impacted by future fluctuations in energy costs. Reduced energy consumption conserves valuable energy reserves for future use and reduces emissions in the atmosphere. Choosing the right energy type for the need will also reduce your environmental impact. A more energy efficient home is also a more comfortable home with less drafts and higher humidity levels. Many changes can also improve the property value of your home. Here's a little bit about us. EnergySense provides energy management services to ATCO Gas and ATCO Electric customers across the province. EnergySense was formed just after the turn of the century in response to a need for unbiased information and advice to our customers to reduce their energy consumption and costs. EnergySense has provided over 56,000 home energy evaluations and commercial audits over the years. We're the primary delivery agent for two federal government programs, the Energuide for houses and the eco-energy programs, and continue to offer energy audits in commercial and municipal facilities. We continue to provide information on our website and through our publications in venues like this and in educating students through our ATCO Energy Efficiency Mobile that traverses the province. Our interactive website contains a number of helpful resources including energy fact sheets, tools and calculators, publications, and answers to frequently asked questions. So I'll be reviewing a number of energy efficiency opportunities in each of these categories that will result in energy and cost savings to varying degrees. Even though energy is currently relatively inexpensive, making energy efficiency improvements can improve the comfort levels and possibly the resale value of your home, as well as reducing emissions into the atmosphere. I'll only be able to touch on each of these subjects due to time constraints, but if you have any questions during the presentation, please feel free to ask. In all your home renovations, consider how to make them more energy efficient. Considering that a renovation will be there for the next 20 to 30 years, the incremental cost will be well worthwhile. Choose products and methods that will lower your environmental impact, as well as providing long-term sustainability. When designing your energy efficiency upgrades, review the standards set forth in the Alberta Building Code 2014, and also consider programs such as the R2000 and the Energy Star for Houses programs that go beyond the code. Realize also that utility bills contain both fixed charges and variable charges. We can't do anything about controlling the variable charges and the fixed charges, but we can affect what we end up paying in commodity and variable costs by reducing our consumption. So set back the temperature of your thermostat before bed and while you're away from home. This works best with a programmable thermostat. If you have a consistent schedule, you can basically set it and forget it. Temperature setback can result in some significant energy savings where it is done consistently. As a rule of thumb, for every degree that you set back the temperature over an 8-hour period, you can save 2% on the heating portion of your natural gas consumption over an entire year. So the question is, how much do you set it back? Well, this depends a lot on your personal preferences as well as the condition and age of your home. Older houses that tend to be drafty and less well insulated, they will take longer to return back up to temperature. And so some experimenting may be required to decide what you're comfortable with. Check and maintain the weather stripping indoors and windows annually to provide a tight seal. Also, adjust the catch plates on doors so that the doors close tightly around the weather stripping. Seal up air leakage points in the house with the appropriate caulking or spray foam. Air leakage can contribute significantly to energy consumption in the home, not to mention feeling chilled in the house. Some areas to consider are around the window and door frames, light fixtures, air intakes and exhausts. Regular maintenance and cleaning of your appliances will also reduce energy consumption and extend the life of your appliances. Check your owner's manual for recommended maintenance schedules, and in particular, check your furnace, your hot water heater, your dryer, and your fridge and freezer. Replace furnace filters as recommended, usually monthly or quarterly, according to the manufacturer, and that's to maintain the airflow and to reduce energy consumption from the furnace fan. To increase the life of your hot water tank, regularly draining off a few gallons off the bottom of the tank will help to remove some of the sediment that's collected there. Clean the lint trap off the dryer after each use, and check the dryer vent regularly. Remove frost buildup in freezers and vacuum off the coils of fridges and freezers to help dissipate heat off of the coils. Phantom power, or standby power, is the electrical power that's consumed by devices when they've been turned off, but they continue to draw heat, or draw energy to run clocks and to run the internal programs or heaters. Some devices like televisions and computers can be fully powered off using power bars. But don't try this with your cable receiver, as it'll lose all of its programming. Phantom power can add up to 50 kilowatt hours to your monthly consumption. Consider replacing your incandescent and halogen lighting with more energy efficient LED lamps. LEDs are becoming increasingly available to replace less efficient light sources. Compact fluorescent lamps, while energy efficient, are becoming harder to come by. Dimmer switches can also help to reduce energy consumption while providing a nice atmosphere in the home. Note that if you're using dimmer switches, only LED lamps and compact fluorescents that are designed for dimmers can be used with dimmers. And light switches work as well. Turn off the light when you leave the room. If your attic insulation level is low, adding additional insulation to a value of R50 to R60 is one of the most cost-effective things that you can do to reduce your energy consumption and result in some instantaneous comfort in your home as well. Your home will be stay warmer in the winter and cooler in the summer. So the most common types of insulation in the attic are blown cellulose, rock wool, and fiberglass. And before upgrading the insulation, you'll want to install or replace any exhaust fans and seal off any air leakage points while you still have easy access. Trust me, you don't want to be doing this after you've already upgraded the insulation. Your attic hatch is a weak point in your attic, so build up the hatch frame to hold back the insulation, insulate and weather strip the frame, and insulate the lid of the hatch as well with rigid styrofoam. An uninsulated basement is a huge source of heat loss. By fully insulating the exterior walls and the main floor perimeter to R22 or better, you can significantly reduce your energy consumption and make your basement far more comfortable. Even a small section of uninsulated basement can result in a significant heat loss. So insulating the basement, while it's not overly expensive in itself, the cost can add up quite quickly, though, if you're developing it to be able to have a living space down there. So consider also insulating the basement floor by adding 1.5 to 2 inches of rigid styrofoam. This will make the floor much more comfortable to walk on. And also, if you're fully developing your basement, consider adding a natural gas fireplace or stove to create a cozy living environment. Replacing your standard furnace with a high-efficiency furnace can save you up to 30% of the heating portion of your gas bill. New furnaces have an annual fuel utilization efficiency, or AFUE, from 90 to 97%. And some of the things that you may want to consider are a 2 or 3 stage burner or a fully modulating burner, as well as a ECM or DC fan, which are much more energy efficient than your standard AC fans. ECM fans offer moderate energy savings at normal speed, but it's at their low speed that they have these significant energy savings. Operating the fan at low speed continuously circulates the air in the house and maintains a more comfortable temperature throughout the home. A couple of additional items that I would recommend if you're changing out your furnace is including a motorized damper on the fresh air intake. And that's just to prevent excess air from being drawn into the house. A quality humidifier and a smart thermostat that controls the temperature, the fan operation, and the humidifier. So if you need to replace your hot water heater, you'll have several options available to you. One is to replace it with an on-demand or a tankless water heater. These provide hot water on an as-needed basis, so you're not paying to store hot water. Storage type options include the condensing hot water tank, which is the most efficient, and direct vent, power direct vent, or power vent hot water tanks. Condensing on-demand and storage water heaters can save about 30% on the water heating portion of your gas consumption. Something to be aware of is the electric hot water tanks. These are being found particularly in new homes. Electric water heaters will cost at least 3 times more to operate than a natural gas unit and will have slower recovery times as well. Over the typical life of the water heater, this can mean an additional $4,000 in increased operating costs. As you can imagine, upgrading the exterior wall insulation is an expensive proposition. It should generally not be considered as an energy-saving option alone, but consider the effect on the property value and your home comfort level as well. Look for low maintenance and long-term sustainability in your exterior finishes. Upgrading the exterior wall insulation can be accomplished in a number of different ways, but the most common is to add 1 inch to 2 inches of foam board to the exterior underneath the new finish. So there's a variety of foam boards that are available on the market with different R values, structural properties, and moisture handling capabilities. Windows and door replacement is another option for energy efficiency that you can consider. However, in most homes you will not see the incredible energy savings that are touted in some of the commercials that you may see. In the average house, 10 to 15% of the wall area is made up of windows. And the change in the insulation values between the old windows and the new is really not that significant. As with exterior wall insulation, look at the effect on property value and improved comfort level. When replacing windows, consider triple glazed with 2 low E coatings. While heavier and more expensive, they offer higher energy savings, better UV blocking, and better sound control qualities. Replacing windows also offers opportunities to install different size windows, new window locations, and opening windows where there were once just sealed units. A rule of thumb in energy management circles is to reduce energy consumption first through a better building envelope, and then install more energy efficient, properly sized mechanical equipment. Once this has been accomplished, or at least implemented, alternative or renewable energy sources can be considered. It is more cost-effective to reduce energy consumption than to purchase energy generation. When a major retrofit is being proposed, alternative energy can be factored into the equation. When it comes to replacing appliances, look at the Energuide rating to see where it fits amongst its peers, and for the Energy Star logo that ensures that it is amongst the most energy efficient available. Natural Resources Canada actually offers a website with list of appliances as well as their energy ratings. So it's important to consider the second price tag, that is the energy cost, when you're purchasing appliances. Some appliances are worth replacing right from the beginning with Energy Star rated appliances and energy savings alone. Fridges and freezers in particular can pay for themselves in energy savings where the existing ones are older than 20 years old. Others that come close are dishwashers and clothes washers. These can reduce water and energy consumption and considerably when you choose the most energy efficient models. When appliances start to break down, compare the cost of repairs to the purchase price of a new Energy Star model and its operating costs. If you have a second fridge, how old is it and how much do you use it? If you don't use it much, unplug it while you're not using it. If it's old but you do use it most of the time or all of the time, consider replacing it with an Energy Star model. When upgrading your appliances, consider also the energy source. Appliances that operate on natural gas instead of electricity are significantly cheaper to operate than electric appliances. This includes ranges and dryers as well as the water heaters that I've already discussed. Natural gas is also a greener energy choice and produces significantly fewer emissions than Alberta's fossil fuel-based electricity system. If you're in the midst of planning and doing your renovations, this is the perfect time to extend natural gas lines throughout your house while it's open. Be sure to include a line or two for your patio or deck so that you can operate your barbecue or patio heater or fire pit. Also, you want to avoid electric heating equipment and electric fireplaces. Electric heat in Alberta is just way too expensive. So if you want to have a more do-it-yourself, hands-on approach to your home renovations, or you simply want to learn more about residential building, I would recommend the following books. Keeping the Heat In is actually a free resource that's offered online from Natural Resources Canada, and it goes through some of the basics of energy efficiency renovations and upgrades. The other two go through some more different building options, and they assume that you have a basic knowledge of building construction. So you can find out more about energy efficiency in your home on our website. If you have any specific questions, you're more than welcome to contact us via email or our toll-free telephone number. And if there's any questions, happy to entertain those now. Thank you.
My name's Peter Amarangan. I'm with Habitat Studio and Workshop. I've been building houses for, since the last oil crisis, basically, and interested in energy efficiency. Our core business is mostly fairly high-end single-family houses, but we try to make everything we build as energy efficient as we can. And we built the first net zero energy house here in Edmonton, and kind of use that to up our game in every other respect. So how many people here are here because they're concerned about climate change? Okay, so pretty much everybody. So I'm not going to talk about that, but I am going to talk about one thing here. That I want you to think about. So every time somebody builds a building or does a retrofit, they're actually building a building that's locking in the emissions from that building for the next 40 or 50 years. So the buildings that we're going to be living with, say in 2050, are being built today. And if they're not being built to the standard we want in 2050, we're locking in the emissions from that building. So when you look, for example, at all the buildings that are going up in the Arena District, like these are mediocre, they're better than they used to be, but they're not hugely energy efficient buildings. They're nowhere near what they could be. So we're saddled with the emissions from those buildings from now until they have major upgrades. And at that point, we'll have the option to do energy upgrades rolled into that. But I mean, if you think about it, if you're in a 1930s, 1940s, 1950s house, you probably need new windows and new siding anyway. That's the perfect time to upgrade that building. But if you've got a 2-year-old house, you're not going to do anything to it for two reasons. One is you don't want to destroy that brand new siding and those brand new windows, even though they're sort of better than old windows, but they're not that great. But also the potential energy savings to go from today's code-built house to where it should be is considerably smaller. So the cost to get that saving is much higher. So I say this by way of encouragement to, if you're doing something, like swing for the fences, go the whole way, don't lock us into ongoing emissions. Just a couple things. I'm going to have a net zero energy house. I'm going to talk about this a little bit as we go through. A net zero energy house is one, or building is one that produces all of its own energy for lighting and appliances, hot water and heating over the course of the year on site. But we could build all net zero between now and 2050, and we would not have addressed the problem. Our big problem, the big elephant in the room, the hardest one, is fixing our existing houses. So I'm going to use this little house here in North Glenora as kind of a benchmark for, or just a study point for what I'm going to talk about in the rest of the few minutes we've got here. So this is a family of 4. They're living in this little house. They want to upgrade it, and they're sort of wondering how to go about it. They actually want to enlarge the 2 upstairs bedrooms and maybe add a 3rd one in the same process. So they've kindly allowed me to, together we did an energy model on that as a starting point. But and what we'll sort of take you through possible upgrades to this house. Now, if they were interested in net zero energy, we could do this. So that's the size, that's the size of solar array it would take to get a little house all the way to net zero energy. So it's fairly easy to see that ain't going to fly. So instead, we started by doing an energy evaluation on this house, because we need to know where it's going before we can sensibly address the best way to stop to do anything about it. So this is like a late 40s semi bungalow, and it kind of shows this is fairly typical. It's got the energy loss on this building, and in fact, actually, this is the way this building was built. In fact, on our sort of case study house, the windows have already been replaced with dual glazed windows, and I'll talk about that a bit more in a second here. So that's kind of our starting point. It's a real house. This is a real HOT 2000 model. And now I want to talk a little bit about energy units, just because I'm going to be talking about kilowatt hours for everything, for gas and electricity. So any energy unit can be converted to any other energy unit. And when you're going for net zero energy, and even when you're doing a deep energy retrofit, we're worried about both electricity use and gas use. So to make it easy, I've just converted everything into gas. So I also want to mention the difference between energy that you use in your house and and primary energy. So the primary energy is the energy that goes into getting that energy to your house. And when you're using electricity, and this reinforces to some degree what Jim's saying, when you use electricity, it takes 3.5 units of raw coal to get 1 unit of electricity to use in your house. With natural gas, it's more like 1.6. So you're generally, if it's for heat and electricity, you're better off to stay using natural gas until you get down into net zero energy territory. So just to show this graphically, this is our case study house before any energy upgrades. So for heating, where you can see it's by far the biggest chunk. Hot water is the smallest, and lighting and appliances it's pretty big. And this is based on average electrical use for a typical Canadian house. So I mentioned energy modeling, energy audits. It's really critical to know where it's going before you start trying to do anything about it. And I've seen a few instances where people haven't done this and really regretted it afterwards. I do this, yakking about this stuff fairly frequently. I was in Winnipeg about a year ago, and after a talk, I had two people come up to me. One was a farming couple who built a new house somewhere outside of Winnipeg, and they really wanted to do a good job on it. They put lots of insulation in, but they did double glazed windows, and they hadn't paid too much attention to air tightness. And they would have gotten way more bang for their buck if they'd started out looking at that. The audit, or the energy audit, the energy modeling actually acts as a checklist, so that you don't overlook anything, and you get the most bang for your buck on everything. So you're not putting too much insulation in one area and not in another. So I would say before you do anything major, before you spend any money, be sure to get an energy audit done. It will save you the cost of that audit for sure. And it's also very likely it's the basis of all the incentive programs we've ever had too. You basically had to have an energy audit done before and after. And so take advantage of that. if you can't wait to see what our new governments do, do it anyway. It's really the sane way to do this. So, and kind of just the way it works. When we were building the Riverdale house, we didn't know. We knew we needed high levels of insulation, but we didn't know how far to go in various areas. So we looked at our energy audit. We looked and said, okay, we're losing this much insulation through the basement floor. What happens if we add another R10 to that? How much is that going to cost? And what's the cost for every kilowatt hour that we're going to save year in, year out? And how does that compare with the cost of the last measure on various other parts of the building envelope? And when those are all about the same, then you know you've got an optimum. And so I just really good thing to do. So I won't spend too much time on this stuff because Jim really talked about it very well. But the first step, the least intrusion, you're not tearing out any walls. You just call the guy and they do it. Obviously, the first thing to do, I think, is to improve lighting and appliances. And that means high efficiency furnaces, hot water tanks, efficient lighting. And so this is our test house with those things done, and you can see we've knocked a pretty nice chunk off of there in the heating and hot water energy, and some in the lighting and appliance energy as well. And it's by doing the things that Jim mentioned. I won't dwell on these. Energy efficient appliances will often save you several ways. They'll cut down on the electricity use, plus they'll cut down on the hot water use, which saves hot water energy. The device on the right hand side there is a drain water heat recovery that won't work with the plumbing in lots of houses, but you can actually save 30 to 40% of the energy to heat shower and bath water with one of these things. They're very cool, which I won't go into in too much detail. So then the next kind of relatively easy thing would be to change the windows. And Jim mentioned that you don't get a huge bump out of that. It's true. So this would be what would happen if we took our test house and just changed the windows to dual glazed low E argon windows. They'll probably improve the air leakage of the house a little bit, but it's not a huge benefit. And in fact, this house that we're using as our test house has already had this done by the previous seller, and he did it to make the house easier to sell. Well, our folks would have been way better off if he had just given them the money and let them put it into good windows and upgrading the house. But he essentially paid for that when he bought the house, and it's kind of a lost opportunity. It also, we looked at a house where people wanted to do a deep energy retrofit a few years ago, and they had already done a few upgrades and spent a bunch of money, and that ended up being the difference between them being able to afford the deep energy retrofit and not. So really just underlining the fact that find out where you are before you start. So in upgrading windows, there are a number of considerations. Obviously, you want the highest R-value glass you can get. If the windows face south, it's good to have good high solar heat gain coefficient on that glass, so that any passive solar that you can get will be available. But the energy model will also tell you if you're in danger of overheating from that. Sometimes, it's fairly complicated, but you want the energy model can help you with that. You want low conductivity frames. Some windows have steel in them. They look great. They're vinyl, but they're, you want to check that out. Small profiles. The good part of a window is the glass. It's usually got a way higher R value than the frame if it's a really good window. And so the less frame, the more glass, the better, the more light you're going to get, the more solar gain, less heat loss, and good spacer bars in the glass. And also really good air tightness. Windows are one of the big, as you get everything else solved, windows are one of the big remaining heat loss leaks. And so the really good windows have triple weather stripping. And if ideally, the fewer divisions in the windows, the better. Like a small number of bigger windows with fewer divisions will perform better than windows with a bunch of little bars and frames chopping them up, for the same reason I just said. So there, you know, we're obviously not going to just change the windows. We'll look at a mid-level envelope upgrade here. So it's getting better. This would be adding, say, R10 foam to the outside, upgrading the attic. That's relatively easy to do. Still got the dual glaze windows. Now the house is a little more airtight, or can be gotten to be more airtight in this process. So, you know, the steps involved in that, adding the exterior insulation, never do siding without windows or windows without siding. They go together, they interface, and there's a whole bunch of extra work and cost. You're going to be undoing if you put the windows in and then come back and do the siding later, there's a good chance you're going to end up with a bunch of extra work. If you do the siding today and don't do the windows, same kind of thing. So you have to be a little bit careful in adding insulation, say a foam or insulation with, you don't want to put a second vapor barrier outside of a leaky interior vapor barrier that can trap moisture. So that you know, that's worth checking and need good advice. But in general, you do have the opportunity in that situation to improve the wall portion of airtightness, but we like to take a sort of a cross section of the house and then draw with a red line all the way around the building so that we can either now or strategically as we go through these renovations figure out how to seal off the entire house. Airtightness, once you get the insulation levels in reasonable, really becomes the remaining biggest chunk of heat loss. Also the most economical thing to do, and to replace siding without dealing with airtightness or windows without dealing with airtightness is again another real waste. And your energy model will tell you that. So when you're, older attics, you can just blow more insulation in there, but typically they're very leaky. There's all kinds of little places where partitions join the ceiling, where electrical lines and lights come through. None of those are sealed at all, and they not only are letting air out, but they're also letting a lot of fairly moist air into the attic. So it's really important if you're adding insulation to make sure that you keep that ventilation intact, so that that you're not so that any moisture that gets through there can diffuse out. So there's a couple different choices, and we'll look at so adding it in the existing under the existing roof space. Well, you can usually, if it's a flat roof situation or flat ceiling situation, add a fair bit of insulation in the middle, but you can't add much at the edges, or you'll block off that ventilation. The alternative is what we call a chainsaw retrofit, and I'll talk about that in the deep energy retrofit situation. But you can, and Jim alluded to this, it's really hard to go after these leaks in the attic. We've done it on houses we've upgraded, and it's really, you're crawling around with the insulation, sort of sweeping it over to one side and going up against and trying to keep your head from being ripped open from the shingle nails, and it's messy, but it can be done. But for sure, do it before you put any insulation in there. So the other big heat loss is the basement, and there's a few considerations there. You can see we're now getting down there. So I'm assuming with this bar here that we've still got the dual glazed windows. We've made the house a little tighter, and we're upgrading the basement. So there's two ways to really do that. You can either do it on the inside or the outside. So the inside, you can get a nice continuous layer of insulation, where you could add some insulation to the basement floor, but and and you don't have to do any excavation on the outside or disruption to your landscaping, or you have to worry about working under porches and that kind of stuff. You are going to lose some basement space, and if you've already finished your basement, that's going to make it pretty hard to rip it apart, add a bunch of insulation, and redo all that stuff. So the other option would be to insulate it on the outside, which obviously you're not going to, you don't have to do anything on the inside. There are a couple different ways to do this. You can build a treated wood wall on the outside. At the same time, you can seal any gaps in that foundation if there are any. If you're doing a deep energy retrofit, then your new outside insulation will line up with your new outside wall insulation, which is kind of ideal. It doesn't address the heat loss at the footing that well, but it's a and I was at a conference in the U.S. and there's a presentation on insulating the outside of basements, and I tried to find a photo of it. But you know those machines that the utilities use for finding gas lines and power lines that blast water in and then suck up the mud? Hydrovac, yeah. So these guys were using a hydrovac hose and making a 4-inch trench all the way around the building, and then pouring a special kind of spray foam in there and filling up and waterproofing the house at the same time with no digging. It was very, very cool. And we got all these damn hydrovac machines around here. That's technology that was invented here in Alberta. But it just, and they did an analysis of it, and it was actually, of the three things I've talked about here, it was the cheapest option. So, a little business for some entrepreneur here. We talk about going for broke, hopefully not in the financial sense. The deep energy retrofit, I think, is the way to go. So we're looking at, potentially making the building even net zero energy ready. So this is a building that would be suitable for 2050. So we're looking at walls that be in the R40 range, the attic up in the R80, frost walls at least R20, possibly, preferably higher. Some insulation on the basement floor. It actually doesn't take much to make a big difference on the basement floor. Triple glazed, low E, 2 low E coats and argon-filled windows, thermal bridge-free construction, and very airtight, like passive house airtight. So there are a couple of these going on here in Edmonton right now that I've been helping with. These are friends and colleagues who are doing it on their own houses. And in fact, they're going to do a presentation on these houses much more kind of in depth for the Solar Energy Society at the end of March. Like if you Google SESA, S-E-S-A, they've got a great lecture series that has all kinds of interesting energy upgrade ideas of a variety, and they've got a good archive there too of past presentations. But the first one is over in Ritchie. So it's like a 1940s wartime semi-bungalow, and this is so they've added seven inches of wall on the outside of the house, about 14 inches on the top. They've wrapped the whole thing in a new air/vapor barrier, triple glazed windows, new siding and shingles, and they have also. I mean, this house really needed this work. The foundation was good, but they've also completely redone the interior. But they could have done the deep energy retrofit really without doing much at all on the inside. And they're getting pretty close to where, like, they're comparing now the heat bills that for this year. They're in the house, and they're just kind of shocked. They've gone down to like a tenth of what they used to be. It's really really gratifying. And this is another one over in by Connors Hill. In both cases, these guys hired contractors to do the bulk of the carpentry work on the outside, to do the wood, the air barrier, the insulation, and the new cladding. But they've done a lot of the other stuff and the coordination themselves. And this one here has a south-facing roof. It will be net zero energy for sure. It'll be probably the first real net zero energy retrofit. Well, other than the one we did, but that was a little different. The house had a fire, and we cleared it down to the main floor. The owner of this will talk about this at the same session in the spring. So, you know, in the process here, there's just a couple of little details. How we're getting that extra air tightness in that process doesn't just happen automatically. It takes some care and attention and some thought in detailing it, but it's not rocket science. You know, when you're doing this kind of stuff, trying to deal with thermal bridging gets to be important. We normally ignore it because the heat loss in every other respect is so big that it's not that significant. But as you start to get decent levels of insulation and air tightness, the thermal bridging sort of starts to look like the kind of low-hanging fruit. Like the framing becomes a conductor and a source of heat loss. So trying to get a continuous layer of insulation is really good. So then, if you do get the house reasonably tight, you have to start thinking about fresh air as well, because most houses have, like even your average new house would have about 2.5 to 3 air changes an hour with the blower door on it, and the blower door it subjects the house to about the equivalent of a 30-kilometer-an-hour wind. So not a huge wind, like it's a stiff breeze is all. And we get that often. So in that condition, this brand new house, 2.5 to 3 times an hour, the entire volume of air in that house is out through the cracks, replaced with minus 30 air that needs to be reheated. But that air coming in is also making fresh air. So that's what's keeping you healthy. So when you seal that up, you need to put in a fresh air machine to give you continuous fresh air. And the beauty of these things is that while they're giving you fresh air, they're also recovering the heat from the air that's going out. And it's very well worthwhile in doing that. You know, you look at bang for your buck. Just putting any old HRV in will not get you anywhere near the benefit of a really efficient. You know, there's a couple out there that are highly efficient, that are in the 80 to 90% range. So if you can't do it all at once, you know, at least try to sequence the work so that you're not having to tear stuff you've done apart and redo parts of it at the interface. And sometimes it makes sense to wait a little longer until you can afford to do the whole job. So I want to put in a plug here too for third-party verification. Like, this is feel-good stuff. It's easy to be self-delusional about this, and I can tell you this from looking in the mirror when I'm shaving every morning. So trust me. Knowing that you're going to have to get an Energuide rating before and after to prove that you did what you said you did, and if you're the homeowner, so that you know you're getting what you paid for, because we builders will tell you what we think, no problem, and try to convince you to whatever we think is the best, and it's not always what the energy audit says. But it's well worthwhile to get that third-party verification at some point. And I think the climate panel, one of the most consistent things they heard from in the energy efficiency sector was that we need mandatory energy labeling. So what that means is that you will not be able to sell your house without an energy label, so that when somebody's looking at 2 houses on the street and they can see that this one's a leaky sieve that's using a huge amount of energy, and this one over here has been fixed up and is ready for 2050, people are going to see that it's worthwhile to pay for that and not that. So that I will be surprised if in the near term, even the Canadian Home Builders Association is in favor of this, because it helps to distinguish brand new houses from leaky old houses. And so just another reason to do that. And we're on the verge of bringing in a new Energuide rating system that makes a whole lot more sense. Used to be that you know, our building code around here just changed from the low 60s to or somewhere around the high 70s, but it wasn't it's not a straight line. Going from an Energuide 86, which we consider net zero ready, to 100, really is just adding renewables for the most part. So this will be a much more sensible rating, where a house that uses zero energy per year will have a zero rating. Otherwise, it will be how many gigajoules a year that house is using, and you'll really be able to sort of put yourself on a line with other houses. We're expecting this to be introduced either before the end of the year or early next year across the country. Anyway, so the obvious question is, who can I get to do this, and what's it going to cost? And these are early days. There aren't people who are specializing in this that I know of. We upgrade houses when we do major renovations to them, but not to the deep energy level retrofit that we're looking at that. There's a desperate need for training. I mean, if our government is looking for an employment program, this is a massive undertaking that we need, and there are lots of good jobs out here. But we're hoping at this presentation in March to include costs, so we've got a pretty good idea of where the stuff's going. But I haven't gone to that. I haven't done that. Well, thanks very much.